Hey everyone, welcome back. This is Maddie. In this video, we'll be learning string performance. Before looking into string performance, I just want to discuss one important topic, which is nothing but string concatenation operator, which is the prerequisite for string performance. Whenever we want to concatenate two strings, in Java, what we can do is we can just add two strings using a plus operator. Let us see that. We have a string A equals Maddie, string B equals Cur, and whenever we want to print Maddykar by adding A and B, we can do this way: A plus B. The output of this will be Maddykar. Let me just show you the same in code. Just create a main method, string A equals Maddie, string B equals Cur, print by combining A and B. If I run this program, it will print Maddykar on the console. See, it's printing Maddykar. That's the concatenation operator. Now let us write a small code snippet to print all the alphabets in English. To print alphabets. We know we have 26 letters in English. Since we need to print all the way from A to Z, we need a for loop which starts from 0 and goes till 26 and gets incremented after each iteration. And in the printing statements, what we can do is we can have a character A plus I. I'll explain what this prints on the console. As we have discussed, in Java, characters are stored in ASCII value. Small letter A ASCII value is nothing but 97. For every each iteration, it will add the value of I to 97. In the first iteration, 97 plus 0, which is equals to 97. When we convert this to character, this is equivalent to A. And in the second iteration, 97 plus 1, which is equals to 98. And whenever we convert 98 to character, it becomes B. Then 97 plus 2, which is 99. In character, it is equivalent to C. And this goes till Z. 97 plus 26, which is equals to 123, equivalent to Z. Let us see the same thing in code. By the way, here we have used concatenation operator and the typecasting as well. Let us go to IntelliJ and try to print all the alphabets in English. Let me just comment this out. We'll start the for loop from 0 and goes till 26. I plus plus increment after each iteration and print every character by adding ASCII value of A to I. Let me run this program. It should print values from A to Z. Yep, it's printing values from A to Z. Now let us move on to string performance. String performance. I'll just explain this with an example. Let's take the same alphabet printing code and I want to append output of each iteration to a string variable. Let me just write the program here. String alphabets equals, just have an empty string initially. We'll start the for from 0 and goes till 26. Increment after each iteration. And instead of printing here inside for loop, I'll just append it to alphabet string. Char of a plus I. And after appending all the alphabets, I'll just print out after for loop. The output of this program will be A, B, C, D, E, F, G, H and goes till Z. Now, can you guys think of how stack and heap works for this program? Let me just show you. I'll just have a stack over here and in heap we need little bit extra space. Whenever compiler encounters first line where we have declared alphabets string variable, alphabets reference variable will go into stack and a string pool is also initialized since it is data type of string and it will be having empty string and alphabets reference variable will point to the object. Now when the for loop starts, we are appending a values to alphabet reference variable. In that case, what happens is whenever for loop starts, for loop 1, meaning for iteration 1, let me just write down the iteration itself. Iteration 1, what it does is it takes the existing string plus adds first alphabet in English to this empty string. Output of this will be A, and after iteration 1, this object is created inside a pool and currently pointing pointer will be removed and alphabet will point to newly created object. And in iteration 2, it takes the alphabet value A plus this time it adds up the next alphabet value B, which is equals to AB. And after iteration 2 completes, this object goes into heap string pool AB and current pointer will be removed and alphabet will point to newly created object. And in iteration 3, iteration 3, it takes the value of alphabet which is AB and adds the next alphabet to it which becomes string ABC. And after iteration 3 completes, ABC is created inside string pool and current pointer is removed and alphabet will point to newly created object. Can you observe the pattern here? For each iteration, a new object is being created and it is not modifying the same object because strings are immutable, and an object creation for every iteration is the waste of memory because all these created object will stay in the heap until the heap is full and garbage collection is initialized. And heap is very crucial in large scale applications. A solution for this problem is, what is the problem here? For every iteration, it is creating a new object. That's our problem. For this problem, Java has a different class where we can append a values to a existing string without creating a new object. That solution is called as StringBuilder. Where StringBuilder allows us to modify the string and it will not create a new object for each new string, hence the memory will be saved. Let us write the same code using StringBuilder now. I'll just declare a StringBuilder. Since this is class, we need to create an object of it using a new keyword. New StringBuilder. And write the same for loop again, which starts from 0, goes till 26, increment after every each iteration. Instead of using a concatenation operator, Builder has a built-in method to append a string to it, which is nothing but builder dot append. We need to pass the value character, add I to a for every iteration. We can just print the builder after for loop, which will give the same output as our previous program, but this time for every iteration a new object will not be created. Instead, the same string gets modified for every call, meaning for every iteration. Let me just write down the same program in IntelliJ. Switch the screen. Okay, just comment this out. Declare string builder. Alphabets equals new string builder. Start the for loop from 0, goes till 26, and increment for every iteration. Use built-in method dot append to append each character a plus I. Value of a is added with I for every iteration, and after for loop print the alphabets. This will print all the alphabets in a single line since we are assigning it to a variable. See, it's printing ABCD till Z. Let me just show you how stack and heap works for this so that the concept will be clear to you. I have a stack here and heap, stack, heap. When the compiler encounters first line, that is string builder declaration, builder reference variable will go into stack, and an object is created inside heap with empty string initially, and this builder will point to created object. And when the for loop runs, after every iteration the same string gets appended with new character to it, and the memory address will not be changed. Since the memory address is not getting changed, it won't create a new object for every iteration. Instead, it modifies the same object with different values. I hope the concept is clear. Just to reiterate, we have discussed how string immutability behavior causes a problem to large scale applications, because in large scale applications performance is very crucial, and that problem is solved by StringBuilder class. And in most of the interviews, StringBuilder is used instead of strings if that string gets modified frequently. That's it for this video. In the next upcoming video, we'll be seeing the built-in methods of StringBuilder. Thank you all for watching. See you in the next one.